So good morning to one and all. In continuation of the previous one, next I'll go to sequencing of n number of jobs through 3 machines. Earlier we discussed the case where we have n jobs, we dealt with only 2 machines, now 3 machines. So aim, objectives, and these are the outcomes of the session. This Johnson's algorithm we discussed already earlier, but as I discussed already, this Johnson's algorithm is applicable only whenever there are only 2 machines. But the case here in this problem, we have 3 machines are there. We have 5 number of jobs are there. These 5 number of jobs need to be processed under 3 machines in the order A, B, C. Each job needs to visit A first, B next, C next in the order. Now, how to get the sequence? Here 3 machines are there. The thing is, we can convert this 3 machine problem into 2 machine problem. Whenever the 2 machine problem we have, definitely we can able to apply Johnson's algorithm to identify the sequence. Like that, first we'll convert this 3 machine problem to 2 machine problem. We'll apply Johnson's algorithm, we'll get the sequence. Afterwards, to identify the total elapsed time, to identify the ideal times of these 3 machines, we'll use the as usual procedure. Okay. Now, so to apply the Johnson's algorithm, there is a condition, that is the smallest processing time on machine A should be greater than or equal to largest processing time on machine B. Here smallest processing time on A is 6 and which is greater than or equal to the largest processing time on B. Out of B processing times, largest time is C. Here 6 both are equal. So we can use Johnson's algorithm, there is no doubt. Now, the 3 machine problem can be converted into equivalent 2 machine problem. Let us take those 2 imaginary machines are capital G and capital H. Capital G is nothing but just add the processing times of A and B. H will get by adding B plus C. By adding the processing times like this, definitely we can able to convert 3 machine problem to 2 machine. See, this is 3 machine problem. Now this is 2 machine problem. How we got this? Simply by adding these two. 8 plus 5 13. 10 plus 6 16, 6 plus 2 8, like that we got machine G values. Machine H values obtained by adding B plus C. Now the 3 machine problem converted to 2 machine problem. Now for this we can apply Johnson's algorithm. By applying the Johnson's algorithm, the sequence obtained will be 3 2 5 4 1. Otherwise, let me explain how this sequence is obtained. Like earlier, take a 5 machine, here we have 5 jobs now. So take one empty sequence with the 5 slots. Out of all these processing times, the least processing time is 8. This belongs to G, the corresponding job is 3. Since it belongs to G, you have to place 3 in the first. Afterwards, you remove this. Now you see the beauty of this problem. Now out of the remaining 8 processing times, the least processing is 9, which is repeated for 3 machines continuously. What is the first machine? The first job, the corresponding machine number is H. So job 1 need to be placed in the last since it belongs to H. Remove this. Next, job number 4, the same processing time, keep in the last. Job number 5. Why we are keeping towards right side means since these processing times are least and these are belongs to machine H. 5. Finally we left with only one, that is 2. See, now the sequence is 3 2 5 4 1. Now take the existing sequence 3 2 5 4 1. Now like earlier with the given data of the 5 jobs, 3 machines and processing times of those 3, please try to identify for the first machine, the first job, the time in will be 0. Next, based on the given processing times, you try to estimate the time in and time outs. Next, for machine B, for machine C also estimate time in and time outs. The process I explained you while we are dealing with the n number of jobs and 2 machine problem. The same process, the same processor here you can apply. Now the thing is, finally at last, from this problem we have to identify what is the total project or this particular project completion time. Okay, this problem completion time. See, we can able to complete all these 5 jobs under all these 3 machines in 51 minutes. Okay, the total minimum elapsed time will be 51 minutes. Now, what is the ideal time of machine number A? You see, the total elapsed time is 51. Ideal time on machine A. Machine A, initially it started with 0 and here there is no waiting time, but at last the total completion time is 51 minus, under machine A we are completing all the jobs by 42. So 51 minus 42, it's 9 minutes. 9 minutes is the ideal time for machine number A. Now coming to the machine number B, initially machine B is waiting for 6 minutes. Next, the job, see job 3 is completed here at 8th minute, the next one is started 16. Here you see 8 minutes it is waiting here. For the next job it is waiting for 5 minutes. For the next job it is waiting for 3 minutes. For the next job it is waiting for another 5 minutes. At last the total completion time is 51, it is completing by 47. Here another 4 minutes. So 6 plus 8 plus 5 plus 3 plus 5 plus this 4, which gives the total machine B idle time is 31 minutes. Okay, now come to the last one. See here, initially it is waiting for 8 minutes, 8, next 22 minus 16, it's 6 minutes. Here no waiting, here only 1 minute, and here another 4 minutes. In total 8 plus 6, 14 plus 1, 15 plus 4, 19 minutes. Machine C idle time is 19 minutes. Like that, using Johnson's algorithm, we can able to solve the problems where the 3 machine problem can be converted into 2 machine problem only for identifying the sequence. Once you know the best sequence of the jobs, using that for all the machines, the time in timeouts need to be estimated based on the given data, given processing times only. At last we can able to identify the total elapsed time, the total completion time of the entire problem, and also we can able to estimate the ideal times for the 3 machines. Like this you have to solve n jobs 3 machines problems. Here jobs will be n, that may be 5 or 6 or 7, whatever it may be, but the machines must and should be 3 only. Okay, and the activities and case studies mapped in the session are mentioned here. These are the examples. Summary. In this session you have learnt about how to apply Johnson's algorithm, the case whenever you have n jobs and 3 machines are there, that we discussed, and we sequence n jobs using 3 machines to minimize the total elapsed time also. And these are the self-assessment questions. You see, in a sequencing problem involving n jobs and 3 machines, what is the primary objective? The objective is always to minimize the make span. Which of the following rules we are following to minimize the make span? That is longest processing time, LPT rule only. The terminal questions mapped to the session are mentioned here. These are the books to refer. Thank you very much.